Hello and welcome students. This is the lecture on derivative which we are doing as a part of covering basic lectures, basic calculus for physics. So here I will solve one question. Let's solve this. It is from 11th standard textbook. Maharashtra State Board. Exercise 9.2. Problem number 3, fifth. So here we have to differentiate. The question is differentiate the following. Differentiate with respect to x. Differentiate with respect to x. So I'm given y equals to sine of x multiplied to log of x plus e raised to x multiplied to cos x minus e raised to x multiplied to root x. So here what you see is you have three terms here. You have three terms. Sin x into log x is one term, plus this is second term, and here you have third term. Moreover, what you notice is in these three terms, each term you have product of two functions. Sin of x is one function multiplied to log of x, another function of x. E raised to x is multiplied to cos of x. E raised to x is multiplied to square root of x. So in each term you have product function. So when you will differentiate this with respect to x, as it is required, we have to differentiate the given function with respect to x. So when I will write here differentiating with respect to x, both sides. So as you know students, you would write d by dx of y on the left, and here you will write d by dx of this full thing. Okay, where you have this first term plus this second term minus this is third term, right? You will have these terms here. You write this here, and this here. Then you will write d by dx of each term separately. So you have d by dx of the first term, and the first term has sin x multiplied to log of x plus d by dx of second term you have, which is e raised to x multiplied to cos of x minus d by dx of third term, which is e raised to x multiplied to square root of x. And on the left side, you have d by dx of y. Then you will apply the product rule. This is, you have sine of x multiplied to log of x. So this is u and this is v. So we have d by dx of u into v. Product rule, d by dx of product of two functions is u d by dx of v plus v d by dx of u. Okay. Then now you go for next step. So on the next line, you will write d by dx of y equals to, what was the first term? It was sin x multiplied to log x. Sin x multiplied to log x. So here you have sine of x d by dx of log of x plus log of x into d by dx of sine of x. Then you have e raised to x multiplied to cos of x. So plus e raised to x d by dx of cos of x plus cos of x d by dx e raised to x. Then after this we have negative. We differentiated this one. Now we have a negative sign, and then we have d by dx of product of e raised to x and root x. So I write minus, and now as you know students, whenever you apply a product rule, you can check here, whenever you apply product rule, you end up with two terms. See, this is the product rule for the first one. This is product rule for the second one. So whenever you apply product rule, you end up getting two terms with a plus sign in between. With a plus sign in between. Okay. So same thing would happen here also. You know, for that, what we will have to do is we will have to start with a bracket. I will have to put a bracket, and inside the bracket, I will get two terms and a plus sign in between. Why I need to put a bracket? Because outside I have a negative sign here. You can check the negative sign. Okay, for these two, I did not have to put any bracket because outside we had positive sign. See, this was positive, and here also it is positive. No sign means it's a positive sign. Okay. So we have e raised to x into root of x. So this will get me e raised to x d by dx of square root of x plus square root of x and d by dx of e raised to x. So students, I will get here. Now, after this, it's very simple. Sine x. We all know d by dx of log x is 1 over x plus log of x, and d by dx of sine x is cos x plus e raised to x. D by dx of cos x is minus sine x plus cos x. D by dx of e raised to x is e raised to x. Negative. Now see minus e raised to x. D by dx of root x is 1 upon 2 root x. Then again negative sign. Though we have a positive here, you can check, we have a positive here, but outside it's negative, outside the bracket. So that would become negative. Negative root x, and d by dx of e raised to x is e raised to. So as such, there is nothing big that you can do except taking a negative sign, except taking e raised to x common from these four terms. You can check here, you know, each one of them has a 4. Each one of them has e raised to x. Nothing more can be done. So I write here sine of x. I write here sine of x divided by x plus log x divided by, into cos x. And from all these terms, I can take e raised to x common. E raised to x is common. So I got negative sine x plus cos x upon minus 1 upon 2 root x minus root x. Okay, and this is our final answer, dy by dx. That's it. This is our final answer. I hope you must have understood. You can solve many such questions. Thank you. Now we will take few problems on division rule where we apply the u upon v rule. That is, if we have d by dx of quotient of two functions u upon v. So as you know, the rule is the denominator is v square and the numerator you write v multiplied to derivative of u minus u multiplied to derivative of v. What is to be noted here? You always differentiate the numerator before the derivative of denominator. See, the numerator is differentiated first and denominator is differentiated second. Okay, you cannot change the order. You can't write this term here. No. So once again, remember the order. What is order? The order is there will be a negative sign in between and you will have derivative of numerator first. So v d by dx of u minus u d by dx of v upon v square. Okay, so we can take few problems, students. So I will begin with uh, from textbook question number 4 and fourth second. So here I have to differentiate with respect to x. So question number 4th and second, I write here, given y equals to square root of x plus 5 divided by square root of x minus 5. Root of x plus 5 upon square root of x minus 5. I write here differentiating with respect to x. So what I notice here that I have got numerator, which is function of x, and denominator, that is also function of x. So I have numerator and denominator, and I have division. I have division here. Okay, so u upon v. This is my u. This is u, and this is v. Okay, so we will apply the quotient rule, the one which I wrote here for. Okay. So differentiating with respect to x, I will get on the left, I get d by dx of y, and on the right, I get d by dx of square root of x plus 5 divided by square root of x minus 5, and the bracket is closed. So I now apply the rule here. So what will I get? I'll write, therefore d by dx of y is denominator. Remember students, denominator multiplied to derivative of numerator. As you know, always numerator is differentiated first when it is division rule. So root of x minus 5 multiplied to d by dx of root of x plus 5, then negative sign, and now it's turn to differentiate the denominator, and numerator will be multiplied. So root of x plus 5 multiplied to d by dx of root of x minus 5, and then you divide by square of denominator, root of x minus 5 square. So here you get you have here root x minus 5, and I put a bracket. See, when I differentiate a bracket, I always put a bracket. So derivative of this and derivative of this. So here I put a bracket first, and d by dx of root x, which is 1 upon 2 root x, plus d by dx of 5, which is 0, minus root x plus 5 in this bracket, the bracket closed. Then I have derivative of root x minus 5. So I put a bracket, and d by dx of root x is 1 upon 2 root x minus 0. And then here in the denominator, I have root of x minus 5, the whole square. This is dy by dx. So now I would like to bring your attention here. See, here you got 1 upon root x plus 0, and here you have 1 upon 2 root x plus 0, 1 upon 2 root x minus 0. And what you notice that you add 0, you subtract 0, you will get 1 upon 2 root x. So from these two terms, this is first term and second term. In these two terms, I have got 1 upon 2 root x common. So in the next step, I will take 1 upon 2 root x common. So 1 upon 2 root x is out. So inside the bracket, I will get root x minus 5 minus of root x plus 5, which is again minus root x minus 5. And the whole thing divided by root x minus 5 the whole square. So this will get me, okay, now this 2 root x will come in denominator. If you have a upon b the whole divided by c, then it is same as a upon bc. It is same as a upon bc. This b multiplies the denominator. So here 2 root x will come in denominator. Moreover, I noticed that root x gets cancelled. Root x gets cancelled here. So I have next step as 1 upon 2 root x. And here I have negative 10 divided by root x minus 5 the whole square. So this is 2, and here in numerator I have negative 10. So it will be negative 5 upon root of x multiplied to so the final answer I will get is negative 5. This is 2. This will be 5. So you will get the final answer as, I write the final answer here. It will be equal to negative 5 upon root x into root x minus 5 the whole square. This is my final answer. This step is the final answer. This one is final answer. I hope you all have followed it. You can again replay to understand much better. Thank you. Now we have another problem on derivative where we have to differentiate a function of x which is going to be solved by using quotient rule, that is u upon v. So you can check here, students, that in numerator we have got u, and the denominator here we have, which I will call it as v. Now this problem becomes more interesting for the fact that the numerator, the numerator has got product of two functions. What I mean to say is, in numerator you have x square multiplied with sine x. So the numerator has product of two functions. So when I'll be applying u upon v rule for differentiating the given function, when I'll be applying u upon v rule for differentiating the given function, I will have to apply u into v rule within that rule. When I'll be applying u upon v rule, where I will take numerator as u, this whole thing will be u and the denominator is v. Now when it comes to u, it will be derivative of x square sine x, which will again follow the product rule. So let's go ahead. Let's see what we have now. So I write differentiating as usual. I will write here differentiating with respect to x, differentiating both sides with respect to x. So I have here d by dx of y equals to d by dx of x square sine x divided by x plus cos x. So this will get me the division rule. So as you know, the rule says always differentiate numerator first. So you have x plus cos x multiplied to d by dx of x square sine x minus x square sine x d by dx of x plus cos x. and here we have x plus cos x the whole square. This is dy by dx. I write the next step. For the next step, I will have dy by dx. Therefore, d by dx of y equals to, I write the division line, and here we have x plus cos x multiplied to. So this is what I was trying to say in the beginning, students. See, I have d by dx of x square multiplied to sin x. So here you will use product rule. D by dx of x square into sin x, you will use product rule, x square multiplied to sin x. So, and as we all know, whenever we are using product rule, we get two terms with a plus sign in between. Okay, so since I'm going to get two terms, I will put a bracket here. Okay, I will put a bracket here, and inside the bracket I will differentiate these two. So see here, x square into derivative of sin x. What is derivative of sin x? It is cos x. I'm writing, without writing d by dx of sin x, we have solved many problems, so now we can write it directly. So x square cos x plus sin x into derivative of x square. So sin x and derivative of x square is 2x. Sin x and derivative of x square is 2x. Sin x into 2x and the bracket closed. Then we have minus, I have here x square sin x, and again d by dx of x plus cos x, which is, you know, it is x plus cos x. So it is just sum rule. D by dx of x plus d by dx of cos x. D by dx of x is 1 and d by dx of cos x is negative of sin x. So you have plus negative of sin x. So that will be 1 minus sin x. Okay. And down here you have x plus cos x the whole square. X plus cos x the whole square. So now what I do is, I multiply these brackets. Okay, this here in this bracket I have got two terms, and here also two terms. These two will get multiplied, and here also I'll have to multiply. So see here what I get. First I multiply x, so this gets me x cube. It gets me x cube cos x plus 2x square sin x. Okay, x multiplies these two terms, then cos x will multiply. So I will get x square cos square x plus, here I get cos x will multiply. So you will get x into 2 sin x cos x, that is sin 2x, x into sin 2x. Here you have cos x. This cos x when multiplies here, so you will get cos x into sin x into 2x. Now you know 2 sin x cos x is sin 2x. So x into sin 2x you get here. Then you have to multiply this. So you multiply x square sin x with 1. So you get negative x square sin x. And then you have negative here. So it will become positive, and x square sin square x. X square sin square x. Down here you have x plus cos x the whole square. X plus cos x the whole square. Now what I shall do is, I will search for something if I have common. So see here, students, I have x square cos x, and here I have x square sin square x. Okay. So I take plus x square common from these two terms. I take x square common. So when I take x square common, now you can check that these two are positive terms. Both of them are positive terms. This is positive. This is also positive. So when I would take x square common, I will get what? Cos square x plus sine square x. I will get inside the bracket, which is equal to 1. So remember, this plus this is only x square, because after taking x square common, I will get cos square x plus sine square x, which is 1. What more can we have? Yeah, one more thing here I notice is, here I have 2x square sine x, and this is negative x square sine x. So that will get me x square sine x. It will get me x square sine x. So I begin writing the steps here. So I have here, okay, better I go to the next page. I will go for the next page. So it gets me, therefore, d by dx of y, d by dx of y equals to, I get here, as I told you, I take x square common, so I will get sine square x plus cos square x. And then I told you that I have two. Okay, so this one I have taken care of. Fine. And then I said that I have 2x square sine x minus x square sine x. So I will get here plus x square sine x. I will get here plus x square sine x. Okay, further then here I have x cube cos x plus x into sine 2x. So x cube cos x plus x into sine 2x, and the denominator was the same since the beginning, which was x plus cos x the whole square. So you have now dy by dx equals to dy by dx equals to, you will write here x square into 1. This thing is 1. Okay, so x square into 1 is x square plus x square sine x plus x square sine x plus x cube cos x plus x sine 2x, x cube cos x plus x sine 2x, and divided by x plus cos x the whole square. X plus cos x the whole square. X plus cos x the whole square. So if I take x square common from this, I will get x square common. So 1 plus sine x I will get. So what I do here is I take x square common from these three terms. Okay, because here I have got x cube. So if I am taking x square common from the first three terms, what I get is I get x square common. So I get 1 plus sine x plus x cos x. Okay, and the last term I write as it is, x sine 2x, and denominator here I get is x plus cos x the whole square. This is my final answer. I don't think we'll be able to do anything more after this. You can just rewind you can replay the part and check this. Thank you.